Hello friends, welcome to the Otago channel. This video is all about reactive programming in Kotlin. We used to use RxJava, but nowadays by evolving the Kotlin language, we have Flow. Flow has so many functions to make our reactive implementation very concise and easy to read. But sometimes they are a bit confusing, maybe because they are a bit too abstract and we don't really know which function we have to use based on our use case. Today I want to talk about 4 of these extension functions: flatMapMerge, flatMapConcat, mapList, flatMapList. Look, these are a little bit confusing. Stay tuned till the end of this video, then you will learn all about these functions clearly forever. So the first part is about two similar operations, flatMapMerge and flatMapConcat. These two are quite similar, but they have a major difference. And the difference is about respecting order. flatMapMerge is about time efficiency. It runs the task concurrently without considering the order. First come, first serve. In your case, if you don't really care about the execution order, you can use flatMapMerge. So let's first get into the documentation to have a look to see what is the official definition of this operator is. flatMapMerge operator accepts 2 parameters. The first one is concurrency. It has a default value. I think the default value is 16. It defines the amount of concurrent tasks can be executed. I would recommend to not change it and leave it as it is. And the second one is called transform. As the name says, it transforms a value to a flow. As the document said, this operator calls transform sequentially and then merge the resulting flow with a concurrency limit on the number of concurrently collected flows. It is a shortcut for map.flatMerge. There is also a note in the documentation worth mentioning and considering in your implementation. And it says, even though these operators look very familiar, we discourage its usage in a regular application-specific flow. Most likely, suspending operator in map operator will be sufficient, and linear transformation are much easier to reason about. So think twice before using it. I would like to show you how to use this operator in practice. So let's get into the code editor. To have a reactive flow, first I would need to define an upstream. I would define a flow of numbers. Just like this. Now I want to apply flatMapMerge on this flow. So I have the flatMapMerge, and inside the flatMapMerge we have this closure, which is the transform function, and we want to return a flow. So this flow could be any type of task. In this case, I already defined a function which generates a flow. It could be anything, like an API call or a database query or anything else. In this case, I want to keep it simple and just call this generate function and pass the input value from upstream. Just to make the debugging easier, I would like to add a log at onStart. And at the end, we call the collect function. So in this case, I need to make the main function suspend and just print the result. This is a simple example. What we want to see in this example is how flatMapMerge behave when they get the data from upstream and processing data with this generate flow function, which is a long processing action, and seeing the order. So I will run this example. So I made a mistake here. In this case, I need to pass it to this generate flow to have the input correctly. So then run the function. So first we have printed flatMapMerge log. The order is not right, 1, 3, 2. As I said, flatMapMerge doesn't care about order, rather than it execute the task concurrently. And as soon as data come back, it sends it to the mainstream. On the other hand, flatMapConcat, it does care about the order and execute the task sequentially, unlike flatMapMerge. Let's look at the official documentation about flatMapConcat. It set transform elements emitted by the original flow by applying transform. That returned another flow and then concatenating and flattening these flows. This method is a shortcut for map.flatMapConcat. As the documentation said, it's concatenating the flows. That's the main difference between this one and the flatMapMerge, which is executing the task sequentially. Again, for this operator, the same node is mentioned. Now let's look at another example for flatMapConcat, and then we can compare it with flatMapMerge to see the sequence and order. In here, I just need to have a similar implementation for flatMapConcat. I just duplicate this piece of code and change the function to flatMapConcat and updating these log as well. I just need to run this code to see what is the result. As we expected, the flatMapConcat result in order and it respects the sequence. Unlike flatMapMerge, as we saw before, there is no order. And that's the main difference between these two operators. Whenever we want to use one of these, we have to consider if the sequence and order is important for us or not. And depend on that, we can choose which one to use. To summarize this part, I visualize the differences of these two operators into a table. The next part is about two other flow operators, mapList and flatMapList. It gets only the latest emitted value. Let's get into the documentation to get to know more about these two operators. Return a flow that emits elements from the original flow transformed by transform function. When the original flow emits a new value, computation of the transform block for the previous value is cancelled. You could assume the transform block is a coroutine job, and as soon as a new value received from upstream, the job gets cancelled and a new one gets executed. This way, mapList operator always returns the latest transformation. Similarly, in the flatMapLatest, if a new item comes from upstream, the current flow gets cancelled and new flow will be created. And that's the difference. Basically, if you want to have another flow in your transform function, you need to use flatMapLatest. If you have only some kind of computation, you can use mapLatest operator instead. Looking at flatMapLatest documentation, returned a flow that switched to a new flow produced by transform function every time the original flow emit a value. When the original flow emit a new value, the previous flow produced by transform block is cancelled. It reminds me of the switch map operator from RxJava. Sounds similar. Let's take a look at an example to see how do they look in practice. I've defined flow of numbers as an upstream and applied a map list to these flow, and within the mapLatest I have the transformation. I had just a few logs to debug to see how the code execution look like, and I've defined a fetch item function which could be a long processing task. For simulation I added delay and I fetch the item, and at the end I collect them and print them. Similar for flatMapLatest, but the difference here is we have to return a flow in our transformation coding block, which is here we generate a flow and send it back to the main stream. So let's run the code to see how do they look. Based on the log, process all the input values, but at the end only the latest value get processed. Same for both operator, mapList and flatMapList. I created another table for these two operators and I want to show you the key differences. To summarize, these four operators accept transform suspend function. In this transform coding block, they behave differently. For instance, for flatMapMerge operator, it creates flows for each single value coming from upstream and execute them concurrently. On the other hand, flatMapConcat, it creates flows for each single item coming from upstream, but it respects the order and do it in a sequence. Two other operators, mapLatest and flatMapLatest. These two only deal with the latest item emitted from upstream. And based on that, we can have the rest of implementation in the transform coding block. In the mapLatest, we only can have in some kind of mutation and return the value. But in the flatMapLatest, we need to return a new flow. Means we get the latest value and we create another flow and passing it to the mainstream. Consider for these two operators, if a new value coming, the previous computation or a flow get cancelled and the new one will be executed. Hope you found this video useful. If you like this kind of video, especially about flow operators, let me know in the comment section, then I can create more like this video. Don't forget to like this video and subscribe to the Otago channel. I'm Ali from the Otago channel. See you till next video.